What's up, guys? First lesson, first video on calculations. We're going to start off very simple. Let's start off with the foundations of this with formula mass. So very simply, when we're talking about formula mass, we're talking about the mass of 1 mole of a substance. Be that ion, be that molecule, whatever, be that atom. So here, what I mean by that is we're going to pay all of our attention to our little numbers inside a chemical formula of something, but if we have any numbers in front of it, we're going to ignore it. And when it comes to calculating reacting mass, that's going to become very, very important. So let's do a few examples together and then give you an opportunity to have a few a go before I go through them at the end of the next video. So periodic table, if we take lithium first of all, we've got the big number there, our relative atomic mass is 6.9. And the way I like to set this out, the way you should be thinking about it, is we're putting the number of our atoms here, which is 1. We've only got 1 lithium here. And then we're putting our 6.9 in brackets, and we're going to put that in our calculator. And when I say that, we're literally going to do 1 times brackets 6.9 close brackets equals, and there we're clearly going to get an answer of 6.9. Let's get a bit more difficult. O2. So this time we've got 2 of this molecule. We pay attention to our little numbers, and we've got a relative atomic mass of 16. So 2 lots of 16. We put that in our calculator. We get to 32. And I think particularly with calculations, get in the habit of underlining answers so it's really easy for the examiner to search for the answers. Or even a little flourish, little circle maybe, whatever you like. Anyway, next, NaOH. Again, we've got a proper compounds here, so let's get into it. We've got 1 lot of sodium, and our relative atomic mass for sodium is 23. 1 lot of 23. We've just done oxygen, so plus, we're going to add all of these relative atomic masses together. We've got 1 lot of oxygen plus 1 lot of hydrogen, which is 1, as you can see up here. And again, we put that into our calculator and we get to 40, a lovely round number. Next, H2SO4, we need to be paying attention to our little numbers here. So there we've got 2 lots of hydrogen. If we look at our periodic table, we've got a relative atomic mass of 1 for hydrogen, plus just the 1 sulfur. So if we take sulfur here, 32.1. Plus 4 lots of oxygen. So we've already seen that, 4 lots of 16. And again, we put that all into our calculator. We get to 98.1. I thought it'd be worth explaining the next couple. So aluminium hydroxide, when we've got our brackets here, essentially this is what we're talking about. We've got 1Al, we've got no number around that, but hydroxide is what we call a polyatomic ion. So what we have are little OHs going around like this. These have negative charges. These have a 3+ charge. So what we have are essentially 3 of these. Copy. 3 of these ionically bonded to 1 of these. When we look at structure and bonding, we'll see that's very much a ratio as opposed to 1 molecule. But for our purposes, this is perfect. So we have 1 lot of, what's aluminium? 27. 1 lot of 27 plus 3 lots of oxygen. 3 lots of 16 we've already seen, plus 1 lot of hydrogen, which is 1. We've already seen that a few times. And there we get to 78. Let's circle our answers. Let's go back and circle the rest as well. Perfect. I don't know why it's boxed it. Right, next one that's worth its explaining. So here we've got, say, a copper here, and we've got a sort of a ratio with our sulfate attached to it. Now, what this means, this dot, this is called a hydrated salt. So what we have here are 5 water molecules surrounding our copper sulfate, okay? So this is the only time when we have this full stop and then 5H2O. This is the only time we pay any attention to these big numbers. Otherwise, we're only looking at these little ones. So worth us knowing that, particularly when it comes to tougher questions later on. So there we have 1 lot of what is copper, 63.5, plus we've had sulfur before, 1 lot of 32.1, plus 4 lots of oxygen, 16. And this time we've got 5 lots of H2, so we've got 10 lots of 1, plus 5 lots of O, 5 lots of 16. And again, we put that into our calculator, we get to 249.5. So again, follow these steps for now. This might happen more in your head later on, that's absolutely fine. And then give these questions a go. Let's go back to the previous thing that we looked at. We looked at successive ionization energies, and we're sketching a graph for nitrogen. So nitrogen is here. So we remove 1 electron, 2 electrons, 3. So we're going to expect a slight jump here between this electron and this electron because we're going from P to S. They're expecting another electron and then another big jump when we come down to here. So what I expect to see is something that looks like this. Not much, not much, not much. Then a little jump when we move from removing an electron from a p orbital to an s orbital. Then a little one, then a little one, and then a much bigger jump. And we obviously join those together as well. See you next time.